Zhongzhong, a monkey clones Qiangsun and Mumingpu. Chinese Academy of Sciences, Shanghai. For the past decade, Mumingpu, the director of the Institute of Neuroscience in Shanghai, has been on a quest to make monkeys that can be used to study human disease. Today, researchers in his institute announced a major milestone: the births of Zhongzhong and Wawa, the first two monkey clones created using the same technique behind Dolly the sheep. Their names together form Zhonghua, meaning the Chinese nation, a people, a nod to their national importance. China has invested heavily in primate research in recent years, as the United States and Europe have pulled back. After Dolly's birth in 1996, scientists quickly figured out how to clone mice, pigs, dogs, cats, cows, and more. But primates long proved elusive. In 2003, after scientists at the University of Pittsburgh used 716 eggs and failed to create a single clone, it was suggested that primate cloning, and by extension human cloning, is impossible using this method. Zhongzhong and Wawa Qiangsun and Mumingpu. Chinese Academy of Sciences. In a recent interview in POO's office in Shanghai, he told me that human cloning is absolutely not his intention. That, he said, requires its own ethical debate. But he wants to use cloning to expand the number of genetically modified monkeys, which are becoming easier to make using CRISPR. For example, in 2016, scientists at the Institute of Neuroscience in Shanghai created monkeys with a mutated form of the gene MECP2, which is linked to autism spectrum disorder. The genetically modified creatures ran in circles and avoided other monkeys, behaviors that may echo children with the MECP2 mutation. Yet, says Pu, the monkeys led to very little progress in understanding the disorder. It is a feasibility demonstration that we can manipulate genes in monkeys, but it's not a disease model, he says. Different monkeys had copies of the gene in different parts of their genome, and the resulting behaviors varied. The technique used to create the MECP2 monkeys did not give scientists enough control. Similar problems can arise with CRISPR, a gene editing technique that has been widely adopted in different organisms across the world. You can't test new drugs on monkeys whose manifestations of disease are so different from one another. With cloning, it is possible to genetically modify monkey cells in a dish, grow the cells in large numbers, and then create clones from them. The last step requires taking DNA out of the genetically modified cells and putting it into an egg, a procedure called somatic cell nuclear transfer. Zhongzhong and Wawa were created this way, as was Dolly the sheep. In 1999, scientists created Tetra, the cloned monkey, by splitting an HL embryo into two, similar to the way twins are normally formed. This technique can create only a limited number of genetically identical monkeys. Unlike previous groups who have tried to clone primates unsuccessfully, Qiangsun at the Institute of Neuroscience in Shanghai added two complex molecules after transferring the DNA. These molecules seem to alter the expression of genes, in particular, by unblocking genes necessary to reprogram a differentiated cell whose fate has already been determined into a stem cell that can turn into anything. The molecules had been used before in other animals like mice but never successfully in primates. The DNA from which Zhongzhong and Wawa were cloned came from fetal fibroblasts, a type of cell in connective tissue. The team also tried using DNA from adult monkey cells, but the only two monkeys cloned this way died shortly after birth. The cloning efficiency is still low, though comparable to that in other animals. To create Zhongzhong and Wawa, the team transferred fibroblast DNA into 127 eggs. Of those, 109 developed into embryos, and 79 were transferred into 21 surrogate monkey mothers. There were 6 pregnancies and just 2 births. Given these numbers, cloning genetically modified monkeys will remain very expensive. Cloned and genetically modified monkeys, says Christopher Navarra, a biologist at the University of Texas at San Antonio, could be very useful for studies of some diseases, but less so for others. Childhood disease could be studied in young monkeys immediately. Aging-related disease like Alzheimer's or Parkinson's would take decades, though. Crab-eating macaques, the species to which Zhongzhong and Wawa belong, to 25 to 30 years. It's also unknown whether cloning creates other health problems. While concerns about Dolly's premature aging may have been overblown, clones can be abnormal at birth. And no one knows what health issues may be specific to primates. That's why Anthony Perry of the University of Bath is cautious about using clones of genetically modified primates to study human disease. You wouldn't use this approach with all these unknowns, he says. If you want to make a genetic model of disease, the last thing you want is use a model you don't know much about. Zhong and Wawa may soon tell us how cloning affects primates. They are just two for now, but the Institute of Neuroscience expects more clones to be born in the coming months.